我和江河，我和江河，哆咪呜，哆咪呜，嗦哩嘛叮，嗦哩嘛叮，叮叮咚，叮叮咚。We are in the Morningside Park, and this S logo stands for snowman. Today we begin talking about physics of mechanics. Mechanics has to do with building machines. The study of building machines begins with the study of motion, forces, and energy. As you just saw, I skateboarding. I move faster or slower, and motion was controlled by force. I had to paddle to make myself to move. Paddle is the force. However, to keep myself moving, I have to continuously apply forces over a long distance. Recall, in the first episode, we discussed to boiling water, we had to continuously apply heat. In the mechanical aspects, we conclude that to get the work done, we either have to apply forces over a long distance, or we apply force over a long period of time. If you can memorize these two lines, you already understood 80% of the physics of mechanics, because all mechanical machines are built based on these two principles. Let's look at closely at the first principle. To get the work done, we need force and distance. The magic is that the two are interchangeable, meaning that to get the same work done, we can use a very small force, but with a very long distance. Galilei famously said, "Give me a pivot point, I can lift the earth." He meant exactly this. He applied a very, very small force, but over a very, very long distance is equivalent to have a giant with a humongous force to lift the earth. Today we want to testify the first principle. Everyone knows that to lift a heavy object, one can use a ramp. Like that. This is exactly due to the first principle, because we increase the distance from this much to that much. Therefore, we reduce the force. We also know that one can further reduce force of lifting by increase the slope of the ramp. Okay. Because now the distance is even longer. Today I want to tell you something you may not know. You may not know that we don't have to lower the slope of the ramp to reduce force. In many cases, lowering the slope is not an option. All you need to do is to go zigzag. That will also reduce the force because the distance is elongated. If you are a bicyclist, you probably know that if you want to ride uphill, you don't go straight up. You move your handlebar left to right, right to left, because you want the front wheel to go zigzag. If you don't have a bike or skateboard, you should still try this experiment. Simply walk uphill, not to go straight up, but go zigzag. Or open up your hip, walk like a duck. You will see that your walking experience become much easier. What if it's not uphill but stairs? Walking like a duck doesn't help, but still try walking diagonally. you should feel the difference. Lastly, I have a question for you. What if we go downhill or go downstairs? Shall we make a straight pass or make diagonal pass? Now we are not against the gravity. We want the gravity to do the maximum work. So we should go straight down, not diagonal. If you want more fun, try this.